If you're an architect and you're trying to tame the absolute complexity of a modern backend, then this is for you. We're going to dive deep into what it really takes to architect APIs that can truly scale, moving way beyond the buzzwords to a practical blueprint for success.
So I want you to start by asking yourself this one question. Be honest, is your backend a confusing maze of interconnected services where every single new feature is a struggle? Or is it a streamlined highway, designed for speed and efficiency? Today, we're building that highway.
The modern API challenge is really all about scale and diversity. You've got web apps, you've got mobile apps, maybe even IoT devices, and they're all trying to communicate with this sprawling backend of dozens, maybe even hundreds of microservices. Look, without a deliberate architecture, this isn't just complex, it's pure chaos.
So where do we even start? Well, we start with an API gateway. I want you to think of it as the single, secure, and intelligent front door for your entire system. It really is the first and most critical layer of control you can possibly implement.
The real power of a gateway? It's that it centralizes all those messy, repetitive tasks. So instead of every single microservice having to worry about security or routing, the gateway handles all of it. It directs the traffic, it validates credentials, it monitors health, and that frees up your backend services to focus purely on the business logic that actually delivers value.
So this brings up a fundamental choice, right? Do you use a managed service like AWS API Gateway for speed and simplicity, or do you build a custom gateway for maximum control? The key insight here is that this isn't a permanent decision. Honestly, for most teams, starting with the managed gateway is the right call. You only graduate to a custom solution when you hit a really specific, complex need that a managed service just can't solve.
Okay, so an API gateway is a fantastic start, but it often presents just a single generic API to the whole world. And as we all know, one size rarely fits all. This is where we really level up our architecture with the backend for front-end pattern, or as you'll hear it called, the BFF pattern.
So here's the core problem that the BFF solves. Different clients have completely different needs. A web client on a powerful desktop, it can handle large, detailed data payloads no problem. But a mobile client on a spotty connection, it needs a minimal, optimized response to save data and battery life. Forcing them to share a single, generic API endpoint creates a terrible experience for at least one of them, if not for both.
And the solution is so elegant, a dedicated backend for each front end. A BFF isn't a core business logic service. Think of it more like a translator. It sits right between a specific client, like your iOS app, and all your internal microservices, and its whole job is to craft the perfect API response just for that client.
Let's walk through how that flow works in practice. The mobile client makes one simple request to its dedicated mobile BFF. That BFF then orchestrates all the complex work behind the scenes. It calls the user service, the product service, maybe the inventory service. It then aggregates all that data, transforms it into a single, optimized payload, and sends it back. The client is completely shielded from all that back-end chaos.
Okay, so we've got our gateway, we've got our BFFs, but to build a truly world-class, resilient system, we need to think about a few more advanced patterns that operate across the entire architecture. First up is rate limiting. At scale, this is absolutely non-negotiable. It's your primary defense against a single buggy client or even a malicious attack trying to bring your system down. And beyond just defense, it's also a business tool. It lets you offer tiered pricing based on API usage. Next, we have observability. In a simple monolith, debugging is pretty straightforward. But when a single request flows through a gateway, a BFF, and 3 different microservices, how on earth do you trace a problem? That's where observability comes in. Using tools like distributed tracing and structured logs, it's the only way to truly understand what's happening inside a complex distributed system.
And for a lot of SaaS applications, multi-tenancy is absolutely key. This is the architectural pattern that allows you to serve hundreds or thousands of customers from a single shared infrastructure, all while making sure their data and configurations are completely isolated and secure.
The great news here is you don't have to build all these capabilities from scratch. The cloud gives you these incredible, powerful building blocks. You can implement rate limiting directly in API Gateway. You can achieve deep observability with services like AWS X-Ray, and you can build resilient multi-region architectures using tools like Route 53.
So we've covered a lot of ground, from gateways all the way to advanced patterns. Let's zoom out now and assemble all these pieces into a single, cohesive blueprint for a modern API layer.
The key takeaway, if you remember one thing, it's this, is to think in layers. Your architecture has to have clear boundaries. At the very edge, you've got security and content delivery. Right behind that, your API gateway acts as the central control plane. The next layer in is your fleet of BFFs, providing tailored APIs for each client. And then finally, at the core, are your actual business microservices. The power of this model is that each layer has a single, distinct responsibility.
And why do we do all this? Well, this quote says it all. This layered approach gives you incredible flexibility. You can swap out a core service or add a completely new client and BFF without having to re-architect the entire system. It allows your architecture to evolve right alongside your business.
So I'll leave you with this final thought. Take a hard look at your current systems. Is your API layer a true enabler for your development teams, allowing them to build and ship features quickly and safely, or has it become a bottleneck, a point of friction that slows everyone down? The patterns we've talked about today are your blueprint for building an enabler,